and when I went through the program, I thought that I may share with you what we are doing in terms of computational chemistry at the University of Mauritius. So it's a long history, which I'll be pleased to share with you. Now, the overview of my talk today, I'll be talking about computational chemistry itself, then its development at the University of Mauritius, at the teaching level, and then what we are doing in terms of research, and then of course I'll summarize, and then if you have questions, I'll be pleased to share with you my views. Now, then, what is computational chemistry? I know that you are all in the computational fields or engineering, but still I'd like to share some of the points that I think are important. Now, realize that chemistry is a branch of science, right? And it has to be experimental. You can't do science without doing experiments. Right. So basically then, chemistry is one of the scientific fields, and thus experiments are important. But then you'll realize that computational chemistry can be useful, can be important. How and why? Now, those of you who have done chemistry at the, I think either at degree level or lower one, so you do have different branches of chemistry, mainly physical chemistry, organic chemistry, inorganic chemistry, and so on. Well, computational chemistry is just one of the branches like these are. Right. Then, what is computational chemistry? This is what I was trying to say. Right. Why it has progressed, and some of importance I can share if you. Right. Now, basically then, computational chemistry, if you really need a definition, it's a branch of chemistry that uses the principles of chemical sciences, right? Principles of computer science to solve chemistry and interdisciplinary problems, right? But then why it has really progressed, you realize that it has progressed with a boost in the computational power. Now, again, you realize that most of the methods that are really used in computational chemistry, the theory, these theories were known since long way back. But then it's just a question of iterations, it's just a question of computing power that really explode the whole thing. Right. Now, the fundamental thing is this equation, which you might, some of you might be acquainted, is your famous Schrödinger equation. Right. Now, so the Schrödinger equation basically then is you can solve the Schrödinger equation only and only for hydrogen atom exactly, because hydrogen atom has only one electron. Surprisingly, today, there is no method for you to solve the Schrödinger equation as soon as you go to 2 electron systems. Right, but then you can't solve it exactly, yes, but then you can have numerical solutions. So this is what is computational chemistry. For any system then, any number of electrons, no doubt you will not be able to solve exactly, but yes, you can have approximate solution, which is near to the exact solution, which is not the exact solution. And you do that by numerical methods. Of course, again, as you are scientists, you have different numerical methods. Some methods may be suitable for a particular system, some methods may be suitable for a particular system, and so on and so on and so on. Right. So basically then, what you are doing in computational chemistry, you are solving this equation numerically. Now, you do have different software available to do this, right? But then you have to be very careful. You have to be very careful. This is now the starting point. You can't just do something in a black box, right? Give the student or a researcher a computer, right? And then try to get something out of it. Now, you know, there is a wrong concept that computational chemistry, you have a computer, right? You have a computer, a hardware, right? You give some input and then you get an output because you do have a database inside the system that is giving you extract. No, it's not like this. This is something known as regression. This is something very different. Here, independent of anything, right? You'll be able to solve the Schrödinger equation and reach the optimum system that you're interested in. You realize the whole thing has developed, and eventually the person who developed this won the Nobel Prize. Right? So there must be something good with it. Right. Now, why I started with computational chemistry? This is something very interesting. Right. So I joined the University of Mauritius in 1999. Right. When I finished my postdoc, right? So I joined the university. I went for the interview. So when I went for the interview, that time the vice chancellor asked me, "What new will you bring to this university?" Right. So I